Hello, and welcome to Sets and Set Operations. My name's Tuesday Johnson. Here are the applications. So we know that a set consists of just a listing of all of its elements. So let's list some elements. Number one, the set of all odd numbers between 2 and 11 inclusive. Well, let's call this S. It's a set. And this set equals, with our braces here, odd numbers between 2 and 11 inclusive. Well, 2 is not an odd number. So I start with the next odd number, 3, and then 5, 7, 9. 11 is included because it says so right here, inclusive. Now, what if we wanted to write the set of all odd numbers between 2 and 2000? We wouldn't want to list every single member of that set. That's a lot. So we might use something called set builder notation. S is the set of all x such that, that's what this little line means, such that x is odd, right? It's an odd number, and x is between 2 and 2000. Notice the notation. 2 is less than x is less than 2000. 2 is less than 2000. Your inequalities always have to make sense, even if you take out portions. And this literally says x is between 2 and 2000. We could represent this last one with a Venn diagram where our first set is odds, our second set is all the numbers from 2 to 2000, and our intersection, our overlap right here, would be all the odds between 2 and 2000. All right, so we could do this in a Venn diagram if it's easier for you to see that way. For a universal set S consisting of Chevrolet, Dodge, Ford, Honda, Kia, Toyota, and Volkswagen, we want to find the set F of foreign car manufacturers. And we're going with corporate headquarters being foreign to the United States. All right. So F is Chevrolet, Dodge, and Ford, all American owned. Honda, Kia, Toyota, and Volkswagen, VW, are the foreign car manufacturers. That's it. Don't overthink it. Suppose we're playing Monopoly with your brother, and he owns both Park Place and Boardwalk. If you're at the community chest, what rolls or the dice are you hoping to avoid if you want to skip your brother's property? Well, here on community chest, we're 1, 2, 3, 4 moves away from Park Place and 6 moves away from Boardwalk. So it seems like we would want to avoid set A equals 4 and 6, right? We don't want to roll a 4 and we do not want to roll a 6. And this is true in the gaming world. But mathematicians are interested in how we roll a 4, how we roll a 6. So all the ways that we could roll a 4 with the 2 white dice that come with Monopoly, we could roll a 1 and a 3 or a 2 and a 2. Right? We have to have 2 dice, so we can't roll a 4 and a 0. There's no 0 on a die. How could we roll a 6? We could roll a 1 and a 5, a 2 and a 4, or a 3 and a 3. All right? That's all the possible ways. All right, so let's look at some other sets. Let's given a set A, B, C, 1, 2, 3, and a set B, 8, 6, 7, 5, 3, 0, 9, and a set C, M, A, T, H, 1, 3, 2, 0. We're going to find the given sets. First of all, A intersect B. Intersect. It's almost like if you put a crossbar right here, we'd have an A for and. Right, A and B. So what is in A and also in B? ABC is in A. There are no letters in B. So we'll narrow our search to 1, 2, and 3. Does B have any of those values, 1, 2, or 3? Yes, it has a 3. So the intersection of A and B is the number 3, or the set containing the number 3. Don't forget those those brackets, because that's our set notation. That's how we know it's not just a number, it's an element. It's actually an object itself. If we're looking at the set B union C, all right, so we'll take union is just like marriage, right? All of B, all of C, everything they have in common. So the first thing I'm going to write down is all of B, 8, 6, 7, 5, 3, 0, 9. And then I'll start writing down everything in C that's not already there, right? B doesn't have any letters, so I wrote down M, A, T, and H. 1 not already written. 3, that's already there. 2, not yet written. And 0, already there. So I don't have to write the repeats, right? The things they share. But I do have to get everything eventually. Order doesn't matter. You could rewrite this as 0, 1, 2, 3, 5, 6, 7, 8, 9, A, H, M, T. But it's still the same set. It's exactly the same set. So write it in an order that makes the most sense to you. Just like in algebra, sets will use parentheses, and it means the same idea. It means work on this first. A intersect C. So I'm comparing my sets A and C, and I want to know what they have in common. Well, this little a here they have in common. They both have a 1, they both have a 2, they both have a 3. Once I find what's in parentheses A intersect C, I can now take that set and intersect with B. What does A, 1, 2, 3 have in common with B? Only the number 3. All right, so 3 is the only element of our set. A intersect C intersect B. Now, just as with algebra, when you move parentheses, we gotta wonder, does it change what happens to the sets? Well, in this case, A intersect the grouping here of C intersect B. So we do C intersect B first. What do C and B have in common? Well, B doesn't have any letters, so it's not that. C has 1, 3, 2, 0. B has the 3 and 0. So we find C intersect B is 3, 0. And if we take that set and intersect it with A, 3 is the answer. So it turns out with these intersections, if you're intersecting all 3 sets, the order doesn't matter. When you start flipping intersections and unions, you have to be very, very careful. Just so you know, that ABC 1, 2, 3 was really hard for me not to sing. It was a hit by the Jackson 5. And come on, Jenny, answer your phone. Tommy two-tone. 8, 6, 7, 5, 3, 0, 9. I don't know. Listen to this song. It's catchy. It's an earworm. All right. So if we're given a set 8, 6, 7, set B 5, 3, 0, 9, and a set C MATH, now we're going to look at some cross products. A cross C. So I want to pair everything in A with everything in B. In C, that letter. A with M, A with A, 8 with T, 8 with H. Oh my goodness, A's and 8s. 6 with M, 6 with A, 6 with T, 6 with H. And I could keep saying these, but check it out. That first component has to be an 8, a 6, or a 7 because A comes first. 8, 6, 7. It's the only first numbers. First elements. We refer to them as elements because they're not really numbers. They are. I'm just kidding. C, right, has the letters math. And you can see here, M-A-T-H, M-A-T-H, M-A-T-H. Using organization as you write these down helps you keep track and make sure that you've listed them all. If we're looking at B cross A, then all of the first values have to be 5, 3, 0, or 9. All of the second values have to be from A, 8, 6, 7. Check it out. 5, 8, 5, 6, 5, 7. 3, 8, 3, 6, 3, 7. 0, 8, 0, 6, 0, 7. 9, 8, 9, 6, 9, 7. Cross product looks a lot like distribution. Right? It's not the same, but it looks the same. It would be related between sets and algebra. 8 goes with 5, 8 goes with 3, 8 goes with 0, 8 goes with 9. 6 goes with 5, 6 goes with 3. Only I put them in the other order. All right. Cross products. Set listed first, first element. Set listed second, second element. Always in pairs. Get them all the way completed. Thank you very much for watching. Be sure to subscribe to Math with Tuesday on YouTube.